All right. So the first thing that I want you to take note of is that we're solving equations. We're solving trig equations. So what we're going to be doing is using our algebra skills and our trig skills at the same time. All right. What you see up here, the 0 pi to 2 pi inclusive, is an example of a restricted area. Sometimes this will be in Trig. Sometimes this will have parentheses around it. Sometimes it'll be like question number 1 on WebAssign, which we'll get to with an example. But tell me what this means to you. 0 pi to 2 pi brackets. Where can I get my answers? Anywhere from 0 to 2 pi. Can I include 0 pi? Yes. Can I include 2 pi? Yes. So it would change then if I just had parentheses. I could not include 0 pi and 2 pi. Even if it were technically an answer, I would not include it if the restriction changed. So the first thing that we're going to do is we're going to look at what the restriction is. And you're going to have to pay attention to every problem because it may be different. Most of them, in fact all of them, on WebAssign are going to be in radian measure. And so this is not one of the ones where you can put in degree and it'll count it correct. You have to do it in radian measure. Okay? So if you see that the restrictions are from 0 pi to 2 pi, then what kind of answers are we looking for? Are we looking for angles or are we going to be looking for ratios? Well, if they tell me my answers have to be between 0 pi and 2 pi, we're looking for angles. 0 pi to 2 pi is 0 to 360, right? Those are angles. Your answers will be angles in radian measure in terms of pi. Follow? Okay. So what we need to do then is think about quadratic equations. Remember solving quadratic equations? You might have to factor into 2 binomials, and then you set each of those binomials equal to 0, and you solve for x. Does this ring a bell? So like x equals 2 and negative 3. And what did that mean exactly? I said that x equals 2 and negative 3. What exactly does that mean? Okay, so what's another word for the solution in a quadratic? Zeros. What else? Roots. What else? X-intercepts. So technically, we're doing the same thing, only we're using trig functions. But we're going to be applying our algebra skills to find angles that meet whatever criteria they give us, right? And we have to consider all possible locations. So usually there's more than one answer, right? With the exception of this one. So this first question says, some angle, sine of some angle on the unit circle is equal to 1. So I'm trying to solve for theta. Just like in your algebra problem, you would be solving for x. I'm solving for theta. Theta is an angle in terms of pi. So what angle on the unit circle has a sine ratio of 1? Pi over 2. Is that the only place on the unit circle where the sine ratio is equal to 1? Yes, that is the only answer to that question. Seems easy, right? Okay. Moving along to the next one. You go. All right, what do you think you should do? Think in terms of algebra. In your mind, substitute the trig words with a variable. So I can subtract what? What term can I subtract? I can subtract root 2. But I'm going to need to add negative sine theta. Moving across the equal sign, you have to change the signs. So this becomes the sine of theta plus the sine of theta equals negative root 2. using the same algebra skills that I would have used if these had just been variables. Yes, ma'am.
So what would happen if you like subtracted the other sine of theta onto the square side?
Nothing. Just another way to solve it. Okay, now what? I have 2 sine theta. I have sine of theta and a sine of theta, and that gives me 2 sine theta. So I put 2 sine theta equals negative the square root of 2. So now what? I'm going to divide by 2. So the sine of theta is going to be equal to negative square root of 2 over 2. Okay. Where on a unit circle, what quadrants is sine negative? So quadrant 3 and quadrant 4. Okay, so that means that I have to have 2 answers to this question. So where is the sine? What angle has a sine ratio of root 2 over 2? They're my 45-degree angles, right? So I need to pull one from the 3rd quadrant and the 4th quadrant. What are they? 5 pi over 4 and 7 pi over 4. Have to be in radian measure. Now, it's okay if you think in terms of degree, 225 and 315. But if your restriction was given to you, 0 pi to 2 pi inclusive, then your answer has to be in radian in terms of pi. Yes, ma'am?
So we basically already did this, we're just doing it like kind of
With equations, exactly. Exactly. We're just going to be using some more algebra to solve the problem. And you're right. When we did inverses, and we were thinking what angle on the unit circle has this, the only thing that we did with that is we gave restrictions that were different from what we have here. Our restrictions for inverses are very specific because we have to meet the one-to-one condition. On here, we're not meeting any conditions other than whatever restriction is given to us, and in this case, it was from 0 pi to 2 pi. And so if you know algebra, and you know the unit circle, this is easy. All right, let's try another one. This is the one I want you to mark that is like number 1 on website. Okay, so, you know, when you're solving an algebra problem, you're doing PEMDAS backwards. So what can I do first? I can add with 1. Now, I know that a lot of these steps you guys are going to do in your head, but just for the purposes of the lesson, I'm going to write everything out. So my first step is 3 tangent squared theta equals 1. Now what? Divide by 3. So tangent squared theta equals 1/3. Now what? Okay, so here's note to self. When I take the square root, I have to do plus or minus. Don't forget, square root is plus or minus. Okay, so now what's the square root of tangent squared? Tangent. Okay, what do I end up with on the right side? Plus or minus? So 1 over the square root of 3, correct? Because the square root of 1 is 1. So this is really 1 over the square root of 3. Is there another way that I could think about that? Root 3 over 3. Okay. So now if I've got plus or minus, I should have an answer where? All 4 quadrants. I should have one answer from each quadrant. Okay. So here's what WebAssign is going to ask you to do. And I'm going to sketch this out just to kind of show you. Let's go through and let's just write our answers in each quadrant. And so early on, we were learning the unit circle. I said 30 degrees has all the 3, 60 degrees is just root 3. So what are we dealing with, 30 or 60? 30 degrees. And so in radian measure, in the first quadrant, that's pi over 6. So I know I've got pi over 6 here. And what about in the second quadrant? 5 pi over 6. And then 7 pi over 6. And then 11 pi. Okay, so I know I got to get all 4 of those answers, but here's what WebAssign says. It says, list your answer in terms of k, the integer k. We did this before on WebAssign. So what I want you to think about is this. Another word for tangent is slope. Okay? So would you agree then that if I started with pi over 6, that 7 pi over 6 is part of the same line? Okay, so here's how I'm going to write that answer. Pi over 6 plus pi k. You recall this from a web assign a couple times ago? So what does pi equal? 180. And so a line is worth 180 degrees. So what it's saying is this. If I go from pi over 6 and I add pi, I'm going to get to 7 pi over 6. That's pi over 6 plus 6 pi over 6, which gets you 7 pi over 6, which is where I need to be. That's one answer. All right? Separated by a comma. I need to get the other two, so what should I do? 5 pi over 6 plus pi k. And so that will get me this line. Starting here at 5 pi over 6 plus 6 pi over 6 gets me 11 pi over 6. All right, that's the way that you answer the first part of the question. All right, the next thing they want you to do is list all of the answers separated by commas in order from least to greatest. So, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Now, why can't I just say pi over 6 plus 2 pi k? It makes me go in one full rotation. It only puts me back at pi over 6, so it eliminates how many answers? 1, 2, 3 answers. I don't get it. That are valid answers to this question. All right, so the first part of WebAssign is going to look like the plus pi k. So it's like with the integer k. And what's k, by the way? The number of rotations that you make. And if I say k is 1, I only want to make one rotation, or I could make a multitude of rotations. Shelby.
Would it have been wrong if you said 7 pi over 6 plus pi over k and get through the pi over 6 plus?
I think what they want you to do is start in the first quadrant and then move to the next quadrant in the order from least to greatest. You technically would get the same answer, but I'm not sure that they would mark it right. You could try it since you have 3 tries. But I think it would be safer to start in the first quadrant and go from there. All right, moving along. I bet you could do this one in one step. What does this simplify to? Cosine theta equals 1/2. Good. Cosine theta equals 1/2. All right, so cosine is positive. Where? First and fourth. That means I should have an answer from the first quadrant and an answer from the fourth quadrant. Okay? So cosine 1/2. I use my hand and I put my fourth finger down to show cosine is 1/2. What angle is that? 60 degrees. So my first answer is pi over 3. That takes care of the first quadrant. Now I need to be in the fourth quadrant. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Now earlier today someone said, why can't you just put negative pi over 3? That is in the fourth quadrant. I totally agree with you. But it doesn't fit the range of 0 pi to 2 pi. Okay? It's pretty easy so far. So far. This is the hardest one. This looks most like what you did when you were solving quadratics. Yes. great strategy to think about this in terms of an algebra problem. So how can I make this look like an algebra problem? Yep. Make sine theta be x. So this would be 2x squared minus x minus 1 equals 0. Now what? I need to factor that. This is a trinomial that needs to be factored. Tell me what you want to do.
And then like we did.
Okay, so there's a problem with dividing it by 2 because you've left the 2 sign and the sign on the left. You have to divide everything by 2. All right, so you've got several strategies for factoring. You've got just simple trial and error. You've got the pants method. You've got the X method. I don't care how you do it, but we need to figure it out. So the method that I like is the X method. So that's what I'm going to show you. If you've got another method and you can do it that way, great. Go ahead. Do it. Here's the X method. In the top, we do the product AC. Well, what is AC? Negative 2. And in the bottom, we put B. What is B? Negative 1. Okay, so I need two numbers that will give me a product of negative 2 and a sum of negative 1. Negative 2 and 1. And it doesn't matter which order you put them in. So I got a negative 2 here and a 1 here. And here's the next step. This is what people forget. You have to do something else. Divide by A. Divide by A. What is A? A is 2. Divide by 2. Divide by 2. See, when you learn to factor and you first started with quadratics that had an A value of 1, if someone had told you that part of the process was divide by A, you would have been used to doing this all along. But you have to divide by A. Now we should reduce this to what? Negative 1 over 1, which is what I'm going to do. Okay. The denominator is the coefficient of the variable. The denominator is the coefficient of the variable. So let's write it algebraically first, and then we'll switch it back to trig. So how can I write the binomial that goes with the left side? Start at the bottom. The denominator is the coefficient of the variable. So x minus 1. Now let's do this side. 2x plus 1.
How did you get the numbers for spot?
They are the two numbers that give me the product of AC and the sum of B. Okay, now what? Let's rewrite this in trig words. Instead of being x minus 1, this is really sine of theta, or even sine of x minus 1. We could just do x's instead of theta. It's just a different notation for an angle. And then 2 sine of x plus 1 equals 0. Okay, now what should I do? Set each binomial equal to 0. All right? So this becomes sine of x minus 1 equals 0. And that sine of x equals 1. Well, where does that happen? Pi over 2. Took care of that side. All right, and then we have 2 sine of x plus 1 equals 0. Simplify this for me. Sine of x equals negative 1/2. I did 2 steps in one. I think we're okay with that. At this level, we should be okay with those 2 steps in one. Okay, so now, sine is negative in what quadrants? 3 and 4. So I've got to get an answer from quadrant 3 and an answer from quadrant 4. All right, so you use your hand and you make it show sine of 1/2. Sine equals 1/2. So what angle am I at? 30 degrees. So I need the radian measure for 210 and the radian measure for 330. So 30 degrees would be over 6, correct?
Yeah.
So pi over 6, 5 pi over 6, so 7 pi over 6, and 11 pi over 6. Okay. WebAssign may ask you to put these in order from least to greatest. So what comes first? Pi over 2, then 7 pi over 6, then 11 pi over 6, separated by a comma. Don't let the factoring hold you back from getting these, okay? Trial and error, pants method, turn it into an algebra problem, whatever strategy you can come up with, okay? Hey, can you check your work on these? That's the beauty of an algebra problem. How do you check your algebra? If you were doing a quadratic equation and you got x equals and x equals, what could you do? Plug them back in and see if they work. You can do the same thing here. Plug them back in and they should work. They should balance. Okay. So really, this one's easy. Sine of theta equals 1, and we're back to pi over 2. That's the only place where the sine of theta equals 1. Some of them will be just that simple. Others will be more like the one where you have to simplify and factor. There's 12 of these, by the way, if you're counting. We're over halfway. What should I do? Subtract it. So I have 4 secant theta equals negative 8. Divide by 4. Secant of theta equals negative 2. Well, I don't think in terms of secant. I think in terms of sines, cosines, and tangents. So secant is the reciprocal of cosine. So this is where cosine of theta would be negative 1/2. And so I use my hand and I show cosine at 1/2, which is 60 degrees. All right, cosine is negative in what 2 quadrants? I need one from the second quadrant and one from the third quadrant. So it's going to be 120 and 240. All right, so 60 degrees is pi over 3. So this one is going to be 2 pi over 3. And then 4 pi over 3. Now, if you have to think in terms of degrees, that's fine. But you got to change it back to radian measure. Just use your conversion if that's what you need to do. If you need to think in terms of degrees, there's nothing wrong with that. Just remember, you're going to have to turn it back into radian measure before you put your answer in. Okay? Okay. What do you think about this so far? Easy? Yeah, if you know algebra and you know the unit circle, this is really not hard at all. There's more to come. I'm doing all of these without identities. When we get to the identities, that's when it gets tough. Okay. Baby steps. We're doing baby steps first. What do you want to do? Add root 3. So cotangent of x equals root 3. So tangent of x would be not negative, you don't change the sign. 1 over root 3, which is root 3 over 3. Okay, tangent is positive in what 2 quadrants? first, and third. It's the same line, right? So it's got to stay in the first and then the third quadrant. So early on I said 30 degrees has all the threes, 60 degrees is just root 3. So I'm looking for 30 degrees. So pi over 6, and then 7 pi over 6. All right, is there another way that you could write that answer? Perfect. Pi over 6 plus pi. Okay. Now, only do that on WebAssign if it tells you to. If it tells you to write your answer in terms of the integer k separated by a comma, it'll tell you. But only do that if it asks you to. Okay? All right.
Is that cosine?
It is cosine squared x. And x, theta, beta, gamma, alpha, those are all just different notations for give me the angle that satisfies this ratio. That's the first step. Add the 1. So 4 cosine squared x divided by 4. Square root of both sides. All right, and what do I have to remember when I do that? Plus or minus what?
1 over 2.
1 over the square root of 4, which is 2. So it's just plus or minus 1/2. Okay, again, cosine 1/2. Where am I?
6.
You got it, all 4 quadrants. So where am I? 60 degrees? All right, call them out. Pi over 3. 2 pi over 3. 4 pi over 3. 5 pi over 3. That's it. Okay, how could I write this if I had to? How could I write it in terms of k? Pi over 3 plus pi k, and what would that get me? That would get me pi over 3 and 4 pi over 3. And then I go back and I say 2 pi over 3 plus pi k, and that gets me 5 pi over 3. You guys are good at this.
Would you prefer us to write it in this condition or with pi over k?
There will be times when you'll be asked to put it in terms of k, and there'll be times when you're asked to list all of your answers. So you need to know how to do both.
So you said pi over 3 plus pi k would be 2 pi?
This one and this one, because they're on the same line. Plus pi k, and that would give you the second and fourth. All right. What's your first step? 3 tangent squared x equals 9. So tangent squared x equals 3. Tangent of x is equal to plus or minus the square root of 3. So that's all 4 quadrants. All 60 degrees. What's your first one? Pi over 3. 2 pi over 3. 4 pi over 3. 5 pi over 3. Same answer as before, right? All right. We're so close. It's a little bit different. What are your ideas? I can't divide by anything yet because order of operations has to be done backwards. So I would have to add and subtract something first if that's the route you want to go in. It's not my suggested route though. If you think about this in terms of an algebra problem, this becomes 2x squared minus root 3x. And if I'm looking at this algebraically, when I see two terms that have something in common, what would I do? Wouldn't I factor it out? So what do you want to factor out? Okay. So cosine of x. Cosine of x, now what?
2x.
So 2 cosine of x, right? If I'm doing this in terms of trig, minus root 3 equals 0. Okay, so now what? So each part equals 0. So I've got cosine of x equals 0. All right, well, where does that happen?
Over 0 pi. Wait, I can't think. I'm sorry. Yeah. 0 pi. I'm sorry.
This is a monomial. Cosine of x is a monomial, one term. This is a binomial, two terms. Okay, each part. Pi over 2 and 3 pi over 2.
Calm down.
Okay, now the next part. 2 cosine of x minus the square root of 3 equals 0. Cosine of x is equal to root 3 over 2. There are 2 places on the unit circle where cosine is positive. First quadrant and where else? First and fourth. So show cosine is equal to root 3 over 2. That puts you where? 30 degrees. So my first one is going to be pi over 6, and then I need to be in the fourth quadrant. 11 pi over 6. Okay, now, if WebAssign asks you to put those answers in order from least to greatest, what comes first? Pi over 6. Then pi over 2, then 3 pi over 2, then 11 pi over 6. Okay, now, someone earlier suggested that you simply move the root 3 cosine of x to the right-hand side. Algebraically, that's not an incorrect step. And if I do that, what would you do next? What would your next step be? If there's a cosine on the left and a cosine on the right, you just cancel them out, don't you? If you have an x on one side and x on the other, you just cancel it out. So here's the problem with that in these trig problems. When you cancel out, you forget to take into consideration what angles on the unit circle would be equal at that point. That's why I'm suggesting that you keep it all on the left-hand side and factor out a common factor so that you don't forget. Okay? Okay. So last one. When we get to the identity section of this, there are going to be so many different ways that you can think about this problem. But right now, just think about it algebraically. If I wanted to turn this into an algebra problem, then every trig word gets its own variable, right? So I could set this up to be x, y equals 2 to y. If I'm trying to keep it consistent left and right, that's what I have. Okay. So we talked on the last problem about the dangers of just simply canceling out from left to right, correct? So what's a better way? What did we do before?
Put it all in this
Put it all on one side, set it equal to 0. I want you to get into the habit of doing that instead of just canceling things out, because you're going to forget to consider valid answers if you just cancel out. So this becomes secant of x cosecant of x minus 2 cosecant of x. I just moved it to the other side. Okay, now I can factor out a cosecant of x. So that's what I'm going to do. Cosecant of x, secant of x minus 2. Okay, so remember we take each part individually and set it equal to 0. So cosecant of x equals 0. So what I'm really thinking is this, and I want to show you what this looks like. Let's do this one. This is 1, 0, and this is 0, 1. I'm just going to put both of those up there. Cosecant is the reciprocal of sine. Okay? It's the reciprocal of sine. Okay, watch. If I put each of these over 1, and I take the reciprocal of sine, what do I get? Undefined. Reciprocal of sine is undefined right there. Okay, now let's do this one. The secant of x equals 2. Well, the reciprocal of secant equals cosine. So really I'm looking for where the cosine is 1/2. It's positive in first and fourth. Cosine 1/2 of 3. 60 pi over 3 and 5 pi over 3. Okay. So ask me your questions. Yes, ma'am.
You're gonna give us ones that are on the circle.
Okay. Ones that you might have to use your calculator with.
Like when we triangle like we did.
Not building a triangle, but ones that you might have to use the calculator with, but not yet. Right now, everything that you're doing is an exact answer on the unit circle. What if you got something like sine of theta equals 2? Sine of theta equals 2.
It's not possible
It's not possible. Why?
because that would mean that the ratio would, if the ratio is greater than 1, I don't know. Yeah, if the ratio is greater than 1, that means one is like on the hypotenuse.
That's right. So if I say sine of theta equals 2, remember our restrictions are from -1 to +1? Well, the sine ratio is y over r. So if the ratio is 2 over 1, that means y is 2, that's a leg, and r is 1, that's a hypotenuse. And in a triangle, the hypotenuse is supposed to be the longest side, so that can't happen. It can't happen even with sine of theta equals 1.01. Anything over 1 or under -1 is not possible. So all of these on, I'm pretty sure on WebAssign, they're all exact. They're all going to be places on the unit circle that you know. And then eventually, yes, we'll get to ones that you'll have to use your calculator for. All right, any other questions? Okay, so